Today's lesson, we're talking about rotating shapes precisely. And so we're going to talk about rotation and how kind of things compare to each other when they're rotated so that we can get that transformation down. So the learning goal is to work on rotating shapes precisely. So for the warm-up today, we look at 4 figures, and in each figure there are 2 of the angles that are congruent to each other, and so we would like to kind of check it out and see which one's which. So in figure 1, looking at those, it looks like angle CBA and angle LHG are congruent because even though they're rotated, or one's rotated compared to the other, they should be the same. FED definitely is not because it's a little smaller. Looking at figure 2, it looks like the first figure or first angle, YZM, is a bit bigger than the other ones, but the other 2, LSR and PBK, look pretty similar, pretty close, so I believe those would be congruent to each other. Figure 3, looking at that, kind of determine which one's which, but it looks like ENC is just a teeny bit bigger than the other 2 angles. So we'll say that DVG and angle XJL are congruent there. Now figure 4 has a lot more going on, but looking at angle CBO, the one in the middle, looks a bit wider compared to the other 2. So even though there's extra lines and stuff, it does look like LHG and DEF are congruent, or at least look congruent to one another. Okay? But despite them being oriented or rotated differently, you can still be congruent. Okay? Go ahead in the book, skip activity 10.2. We're going to move on to the next page, so activity 10.3. So here, step 1 wants us to draw a segment and label the endpoints A and B. So I drew my picture. Letter A would like us to rotate the segment AB clockwise around center B 90 degrees. So making a right angle there. So it's got to be straight up, rotated around like on a clock. And we're going to label it A prime. And then from there, we want to draw a line connecting A and A prime. And so here they want us to figure out what kind of triangle did we just make. So take a moment, kind of think about that. And if you think about it being a 90-degree angle that we drew there, that would kind of make it a right triangle, or a right angle there. A right triangle is when we have a triangle that has a 90-degree angle inside of it, kind of like a right angle. But looking at this as well, it wants us to know what other properties do you notice. And if you think about AB and us rotating it to A prime B, rotating doesn't change the size of our stuff. So those 2 sides are equivalent to each other. They're congruent. So what kind of triangle has 2 sides that are equal to each other? So if they're congruent, 2 sides, that is an isosceles triangle. Okay. Number 2 wants us to kind of start out the same way. Draw our endpoints, or draw a segment and label them C and D. Okay. And then from there, they want us to rotate that CD counterclockwise in the same respect and make a 30-degree angle. So we're just approximately making 30 degrees. Not super exact here, but that kind of looks like 30 degrees. And so we say C prime. Then we do it again from C prime D. We rotate another 30 degrees and label that new endpoint C double prime. And then from there, they want us to connect C to C double prime. And then shade in that resulting triangle. So I'm going to ignore C prime, or the line of C prime D, for my shading. So looking at that triangle, what kind of triangle do we make? Well, if CD are equal to each other and C prime D are also equal to each other, so it's almost like an isosceles triangle, but there's some more things going on here, because you have a right triangle, that C prime D, we made an angle bisector because those angles are equal. And we've talked about an angle bisector before, which that also means that C prime D is perpendicular to C and C prime, and so then that leaves those other angles as 60. So angle C, angle D, and angle C prime are all 60-degree angles, so that actually makes it an equilateral triangle. So all the angles are equal to each other, and all the sides are actually equal to each other in that sense too. So hopefully you understand rotations a little bit more. I do have a Desmos activity that I would like you to go to the unit for assignment list to go link on to, and it's about 7 questions. It should be kind of fun, so please give it a shot, and I'll see you next week. Okay, thanks. Bye.